We're going to learn how to write cell diagrams and line notation. And here I'm going to walk us through all of these steps. So this is kind of like a nomenclature, like a symbolic nomenclature. And then we'll do an example. Okay. So step number 1, write the chemical symbol of the anode at the far left. And so this is back to our zinc copper example right here. Okay, where we already established that zinc is the oxidation half, the anode, and copper was the reduction half, the cathode. So there it is, the anode, and this mirrors the chemical reaction. And we write left to right. So here we can see zinc solid at the far left because the zinc solid starts at the far left of the anode reaction. Okay. And so then if we're drawing this reaction, right, write the chemical symbol of the anode at the far left, symbol of the cathode at the far right, and a double vertical line for connecting the bridge halfway between them. So then once again, here we can see there's the solid copper at the far right, and there it is in our symbol. Okay. And here is our double line that indicates our bridge. In one of these pictures, I showed you a porous bridge. In this picture, it's a salt bridge. All the same, you can see that cations migrate through the salt bridge from anode to cathode, and anions migrate through the salt bridge from cathode to anode. Okay. And so now work inward from the electrodes towards the bridge. Use vertical lines to indicate phase changes and symbols of ions or compounds to represent electrolytes surrounding the electrode that are changed by the cell reaction. So that's just a complicated way of saying, okay, zinc solid goes to zinc 2+. And here we can see that right there. Zinc solid goes to zinc 2+. And we put a line. And so this is really like our symbol for this reaction, our shorthand notation. Okay. And now similarly, at the cathode, copper 2+ gains electrons and is reduced to copper solid. So now we just write this as copper 2+ goes to copper solid with a line between. And if we had any concentrations or dissolved species, partial pressures of gases, if any of that was known, we would indicate that with a parenthesis in these following cells. So let's do an example of that. Okay. So write a balanced chemical equation and the cell diagram. So cell diagram is another way of saying the line notation. So let's note that. Line notation. I cannot spell at all. Oops. Line notation. Okay. So write a balanced chemical equation and the line notation for an electrochemical cell that has a copper cathode immersed in a solution of 1 molar copper ions and an aluminum anode immersed in a solution of 1 molar aluminum ions. Okay. Well, so we need a balanced reaction. So first of all, let's just work on that. So we know that we have an aluminum anode. And at our anode, okay, that's going to go aluminum solid. Remember, the anode reaction starts with the aluminum solid. And aluminum, so here it is. We can see it's going to make aluminum 3+. So Al3+ aqueous. And there's 3 electrons. Okay. So now our cathode has the copper. And so that half starts with the copper 2+. And that's going to gain 2 electrons to make solid copper. Okay. And we need to balance these, and we're going to do that using the same way that we did before, where we want to balance the electrons so that they cancel. Okay. So I want to multiply this half by 2, and that will give me 6 electrons. And I want to multiply this half by 3, and that will also give me 6 electrons. So the 6 electrons will cancel with the 6 electrons here. And my total balanced reaction for this electrochemical cell will be 2 aluminum solid plus 3 copper 2 plus, aqueous. The 6 electrons and 6 electrons cancel. And now that makes 3 copper solid plus 2 aluminum 3 plus. And we should see the balance of atoms and the balance of charges. So I've got 2 aluminums and 2 aluminums and 3 coppers and 3 coppers. On this half, it's 3 times 2 plus to give me 6 plus total charge. On this half, it's 2 times 3 plus to give me 6 plus total charge. So this is my balanced chemical reaction that shows me exactly how many electrons are being transferred. In this case, it's 6, and the correct stoichiometry. But now to get the line notation for this, so we recall, right, we start with the anode at the far left and the cathode at the far right. And we're going to make it look like these reactions, okay? So in my anode, I can start by saying aluminum, solid, and I'm going to draw a line, and we'll say Al3 plus, and in this case, I know the concentration, so I'm going to put a parenthesis, 1.00 molar. And that's just a shorthand way of writing this, okay? And now we'll say double line, so that's my bridge. And now we write it as the cathode half. So that's going to be copper 2 plus, and we were told that it's 1 molar, so we'll include that. And now we put a line that indicates the reaction arrow, and then now that's copper solid, okay? And note, we don't put any of the stoichiometric coefficients in this, okay? So that's why it's a shorthand, okay? This tells me I have an aluminum oxidation at the anode and a copper reduction at the cathode. So that's like my shorthand. And this is like my full balanced reaction, okay? And we'll do some more of these examples in class. Okay, folks, I'll see you in the next video.